In this video lecture, we're going to talk about the conic section parabola. A parabola is a two-dimensional conic section that is such that when drawn, it is either going to open in its standard position, upwards, downwards, right or left. So depending on how we have obtained the equation of the parabola, the pictures of parabolas are generally of the form opening up or down. I'm going to just talk about the up one and the right and left one, which I will just use the picture that is opening to the right. So formally speaking, there is a point on the parabola, say P. There is a line that is called the directrix for the parabola, and the line is the dotted line. So if you take any point on the parabola P, then this point is always at a same distance from the directrix and from a spatial point of the on the axis of the symmetry called focus of the parabola. So this line is called the directrix of the parabola, and we will learn how to find focus and directrix from the equation of a parabola. And similarly here, if you find this distance from the directrix of the point, then there is a spatial point on the axis of symmetry of the parabola, say here, so that the distance between the point and the spatial point on the axis of symmetry, which is called focus, is equal to the distance of the point from the directrix. And it is true for any point on the parabola. Those geometric objects, two-dimensional geometric objects, are called parabolas. So what we will do, given a spatial form of a parabola, the standard form, we're going to try to understand how to know these different information. So as I said, there are two different forms of parabola, one with vertical axis as the axis of symmetry, and the other one is horizontal axis as the axis of symmetry. So if the vertical axis is the axis of symmetry, then the parabola is of the form x minus h whole to the power 2 equal to 4 times p times y minus k, where the vertex is given by h comma k, the focus is h comma k plus p, the directrix is given by y equal to k minus p, the straight line, the axis of symmetry is x equal to h, and the parabola opens up or down depending on the sign of p. Similarly, if the horizontal axis is the axis of symmetry, the standard form of the parabola is y minus k squared equal to 4 times p times x minus h, where h comma k is the vertex, h plus p comma k is the focus, x equal to h minus p, the straight line, is the directrix, and y equal to k is the axis of symmetry. The parabola opens left or right depending on the sign of p. So that's our general setup. With this setup, we are going to understand the different information that we can obtain from a given parabola in standard or general form. As we have seen in circle, if the parabola is given in the general form, we have to do the completion of the square to change it to the standard form first. So the first one, the square term is x and the linear term is y. So this is going to be a parabola which is symmetric with horizontal axis, with vertical axis. So what we will say, first write it as y, and you can start by saying x minus 0 squared, as in the form I need to have x minus h, so x minus 0 is your h square is equal to 4 times p, so p must be 4 to make it 16, times y minus 0. So that is the parabola. It says find the vertex. So remember, the vertex of the parabola is given by h comma k. So the term associated with x is 0, term associated with y is 0 as well. So both of them are 0 comma 0. Or if it helps, you can write down h equal to 0, k equal to 0, p equal to 4 in this problem. So the next one is focus. So remember, in these type of parabola, the focus is going to be the point h comma k plus p. So I will say h is 0, k is 0, p is 4. So this is 0, comma 4. Then I'm going to think about the directrix of this parabola. And remember, in these type of parabola that are symmetric about the vertical axis, the directrix is the line that is parallel to the y-axis, and the directrix is given by y equal to k minus p. Your k is 0, p is 4, so this is y equal to negative 4. That's the directrix. The final information is axis of symmetry. Axis of symmetry is simply x equal to the x coordinate of the vertex. So I get to say that this is given by x equal to 0. The parabola opens up. So since p is greater than 0, the parabola will open up. As long as we have understood this much, the learning objective for parabola is done for us. So see the situation. The focus is at 0, comma 4. Axis of symmetry is the straight line x equal to 0. The directrix is this imaginary line over here, which is y equal to negative 4. Parabola opens up. The vertex is at the point 0, comma 0. X square minus y. So again, x is squared. So this is going to have the axis of symmetry, which is vertical. And you will write it as x minus 0 whole to the power 2. Write the y on the other side and write it as 4 times 1 over 4 times y. Remember, the coefficient of y is 1. So I have to write 1, but I have to write it as 4 times p. So that's what I did. So you can write y minus 0. And then you can go ahead and write down the values of h, k, and p as usual. So h is equal to 0, k is equal to 0, p is equal to 1/4, still positive, so the parabola will open up. Then I need to know the vertex of this parabola. That's h comma k, so 0, comma 0. I need to know the focus of the parabola, and that is h comma k plus p, so 0 plus 1 over 4, which is 0, comma 1 over 4. Directrix is going to be horizontal line parallel to y-axis, and that is given by y equal to k minus p. So I get y equal to negative 1/4. Axis of symmetry. That is going to be given by x equal to the x coordinate of the vertex, so x equal to 0. So clearly this is your axis of symmetry. That's x equal to 0. Parabola opens up. The vertex this time is 0, comma 0 as usual. The focus is 0, comma 1 over 4. The directrix is the imaginary line y equal to negative 1 over 4. And that is what we are supposed to understand given this parabola in the standard form. So in this problem, we have the y term squared. So as soon as I see that, I know that this parabola is going to have axis of symmetry horizontal. So first I said that regroup the x and y terms. So you have y squared plus 2y equal to negative 8x minus 17. Now what? Now because it is general form and I want to go to the standard form, I'm going to complete the square for y. So y squared plus 2 times y times 1 is going to make it 2y. So I need 1 squared added and 1 squared subtracted equal to negative 8x minus 17. Now the first three terms is the quantity y plus 1 whole to the power 2. The negative 1 squared, take it to the right hand side as positive 1 and make it negative 8x minus 17 plus 1. Then write it as y minus minus 1 to give it the form of the standard parabola. You have minus 8x minus 16. What I do now, I factor out the minus 8x. So I write y minus minus 1 square equal to minus 8 times x plus 2. Now write it as y minus minus 1 to the power 2 equal to 4 times negative 2 is the negative 8, x minus 2. And now we are all set, because now I can go ahead and say my h is negative 2, k is negative 1, and p is also called the focal distance is negative 2 units. Because negative 2 is less than 0, this parabola is going to open left. What else we can talk about? Vertex. That's just h comma k. So it's negative 2 comma negative 1. Okay, so the next one is the focus. So to find the focus, we are going to first think about the h value, which is negative 2, add the p or the focal distance negative 2, and don't change the k. So this is going to be negative 4 comma negative 1. For finding the directrix, we still work with the x coordinate of the vertex, but remember this time it is a vertical line. So x equal to, the x coordinate of the vertex is negative 2, and I'm supposed to add the focal distance, which is negative 2. Now subtract the focal distance, which is negative 2. So I get negative 2 minus 2, which is negative 2 plus 2, and that is equal to 0. So x equal to 0 is the directrix. The axis of symmetry this time is horizontal. So I will say it is a straight line that starts with y equal to, and it's the y coordinate of the parabola, which is negative 1. And that answers my question. So what I have in context of the parabola will open left. The vertex of the parabola is going to be the point negative 2 comma negative 1. The focus of the parabola is negative 4 comma negative 1. The directrix is x equal to 0, the vertical line. And the axis of symmetry is the horizontal line, y equal to negative 1. So let's carry on and see the next one. The next one is a little easier, but again, y is squared. So as soon as I see that, I will first write it as 2y squared equal to x minus 1 to separate the x and y term. And now divide both sides by 2. So you say y squared equal to 1/2 times x minus 1. So now to give it the standard form, I will write y minus 0 squared equal to 4 times. Since I need 1/2, I multiply 1/8 so that the product is still 1/2 x minus 1. So now I know h is equal to 1, k is equal to 0, p is 1/8. This parabola has axis of symmetry as horizontal line. So the vertex is h comma k, which is 1 comma 0. Focus, so remember you are just going to play with or work with the x coordinate of the vertex. For the focus you add, so the x coordinate is 1 plus 1/8. And you don't do anything with the y coordinate, so that's 9/8, comma 0. For the directrix, it's still the x coordinate of the vertex. So it's 1 minus the focal distance 1/8. But what I will do first, I will say this is a vertical line, so x equal to 1 minus 1/8, which is x equal to 7/8. So that is the directrix. Axis of symmetry is the y coordinate because it should be a horizontal line. So y coordinate of the vertex. So I will say axis of symmetry is y equal to 0. And since the p value is positive, it should open to the right. So what we have the vertex of the parabola as 1 comma 0. The directrix of the parabola is x equal to 7/8. The focus of the parabola is 9/8 comma 0. And the axis of symmetry of this parabola is the y-axis, the x-axis, or y equal to 0. All right. So let's carry on again, and this time we have 2x squared minus 16x plus 8y plus 32. Now remember, x is squared, so axis of symmetry is vertical. So again, I write it as 2x squared minus 16x equal to minus 8y minus 32, and I did it because I wanted to separate the x and y term. Then the next step is getting rid of the coefficient 2, so I will divide both sides by 2. So x squared minus 8x equal to negative 4y minus 16. Then completion of the square on the left hand side. So x squared minus 2 times x times 4 will make it negative 8. So I need plus 4 squared and minus 4 squared equal to minus 4y minus 16. So I get x minus 4 quantity square from the first 3 terms. Then I have negative 4 squared, which is negative 16. Take it to the other side by adding. So you get minus 4y minus 16 plus 16. Then you write it as x minus 4 whole to the power 2 equal to 4 times negative 1, that's negative 4, and y minus 0 because the negative 16 plus 16 cancel each other. So now I know my h is 4, k is 0, and p is negative 1. Negative 1, so less than 0, so the parabola opens down. And we will write down the other information as well. So vertex this time is h comma k, so that's 4 comma 0. Focus, so this time you're going to change the y coordinate of the vertex. So 4 comma 0 plus the focal distance, and it is negative 1, so that's 4 comma negative 1. Directrix, similar treatment, but this time the line is going to be horizontal line. So I can say y equal to, again, it's the y coordinate of the vertex minus the focal distance p. So it's 0 plus 1, and that's 1. So I get to say y equal to 1 is the directrix. Axis of symmetry, it's vertical. So I will say x equal to the x coordinate of the vertex, and that is equal to 4 units. So see, in the context of the parabola, my parabola is going to have the axis of symmetry at x equal to 4. The directrix is y equal to 1. The vertex of the parabola is going to be the point 4 comma 0, and the focus of the point of the parabola is 4 comma negative 1. Okay, let's see whether we can do one more of similar type. Find the standard form of the equation of the parabola. The given vertex is negative 1 comma 2 and the focus is negative 1 comma 0. So remember, all I need to do is find out h, k, and p. So h is negative 1, k is 2, and I want to know p. So what I see here, the h is not changed, so the change is in the y coordinate. In the focus, I get to say k plus p is equal to 0, but k is 2. That means p is negative 2. So once I know that, then I know that the parabola is going to have axis of symmetry as a vertical line. And what we will say, since the axis of symmetry is a vertical line, the x term will be squared. So I will say x minus minus 1 squared is equal to 4 times, the focal distance is p, negative 2, times y minus k. So x plus 1 squared is equal to negative 8 times y minus 2. And see, it's negative p, so the parabola must open downwards, and it makes sense. The axis of symmetry is vertical, the focus is at the point negative 1 comma 0, and the vertex is at the point negative 1 comma 2. So that answers my question. Again, focus is given and the directrix is given. Directrix is x equal to 1. So if it helps, draw the line x equal to 1. And x equal to 1 is a vertical line. So what does that tell you? Now the focus is at negative 2, 1. That's in the cusp of the parabola. So the parabola must be of this shape, and I'm not sure where is the vertex. We're going to find it out. But at least I know the parabola has the axis of symmetry as a horizontal line. So it will be y squared x. So the square term is y. So now let's keep working on this thing. We know the formulas. So first and foremost, the focus in this situation, since you are changing the h coordinate or the x coordinate for the focus, I will be able to say that k is 1. I did not change the y coordinate, whereas h plus p is negative 2. Also, I know for the directrix, h minus p is 1. So I have two equations, two unknowns, h and p. Let's solve it. So you just simply add them. You get 2h equal to negative 1. So h equal to negative 1/2. That means what? It means negative 1/2 plus p equal to negative 2. So p is negative 2 plus 1/2, which is negative 3/2. And I have the equation of the parabola. As now I know how much is h and k. So I will say this one is y minus k squared. Remember the y term must be squared as the axis of symmetry is horizontal. Is equal to 4 times p, and p we found out to be negative 3/2 times x minus negative 1/2 is your h. So as you can see, the vertex is at negative 1/2, 1. So y is 1 and x is negative 1/2. That's the I'm so sorry. The y is 1 and h is equal to negative 1/2. So it should be the vertex here, and the axis of symmetry of this parabola is going to be this line, which is y equal to 1, and this is the focus at negative 2, 1, vertex at negative 1/2, 1. So the parabola is this way, opening to the left, and p is negative, so the parabola is opening to the left. All right. Find the standard form of the equation of the parabola satisfying the given condition. The vertex is given to us 2, negative 3. Focus is 2, negative 5. So what I observe first, the vertex has unchanged x coordinate to the focus. So h is not changing, k is changing. As soon as I have known that, I'm going to say, well, this parabola is going to be symmetric about vertical axis, because I'm changing only the y coordinate. So one thing for sure, h is 2. Then you can say k is negative 3, that's coming from the vertex, and from the focus, k plus p is equal to negative 5. So p is negative 5 minus k, so negative 5 plus 3, or you can say minus 3, which is negative 5 plus 3, and that's negative 2. Good, because I have the equation of the parabola now. So if you want to draw the picture, you go to the point 2, negative 3, x equal to 2, y equal to negative 3, so 1, 2, 3. This is the vertex of the parabola. Now the focus is 2, negative 5, so x equal to 2, y equal to negative 5. So I go 4, 5, that's the focus. The parabola will open downwards as the p value is negative. So this is the shape of the parabola. The focus, as we have pointed out, 2, negative 5. Vertex is 2, negative 3. And the directrix, well, we know that the directrix is going to be, again, I'm changing the y coordinate only, and I'm saying this is going to be y equal to because this is going to be a horizontal line. The k coordinate or the y coordinate of the vertex, which is -3, and this time you're supposed to subtract the focal distance or p. So it's -3 plus 2, which is -1. So y equal to -1 is the directrix. Axis of symmetry is pretty simple. It's x equal to +2. So we have identified the parabola. Let's see what else we have. Find the equation of the parabola as described. Focus and directrix are given to me. So directrix is y equal to 2. That's horizontal line. As soon as I know that, I know the axis of symmetry as well. So y equal to 2 is the directrix. That means the parabola is going to have axis of symmetry, which is vertical. So if it helps, write it down. Axis of symmetry, vertical. And in these situations, for focus and directrix, we only change the y coordinate. So we know that h is known to us, -5. And then we can say k plus p, which is the focus, is 4. K minus p, which is the directrix, is 2. As usual, add them, you get 2k equal to 6, so k is equal to 3. That means 3 plus p is equal to 4, so p is equal to 1. P equal to 1 is positive. So the parabola must open up with the vertex of 5, 3. So x equal to 1, 2, 3, 4, say 5. 3 should be, this is 1, 2, 3. So somewhere here is the vertex of the parabola. It opens up, so this way. This point over here is 5, 3 as the vertex. The focus is, in fact, it's -5, so it should be in the other direction. Remember, h is -5, so I'm going to change it a little bit. It's going to have the same shape, but it should be at 1, 2, 3, 4, -5 and 3. So somewhere here, so that is your parabola opening up as p is positive. So this vertex is -5, 4, and the focus is at the -5, 3, and the focus is at the point -5, the vertex is -5, 3 because k is 3, and the focus is here, and that point is -5, 4. Whereas the directrix, if I want to know, is given y equal to 2, and the axis of symmetry is the easier one. This is x equal to the x coordinate of the vertex, and that's -5. Okay. Our next problem, it is given in the standard form, and we want to know the vertex, focus, directrix, and of the parabola. Because y is squared, the parabola is either going to open right or left. So I would say y minus 5 to the power 2 equals to 4 times 1 to understand the p. And instead of x plus 3, let's go ahead and write it as x minus -3. So h is -3, k is 5, p is 1. So vertex of the parabola is -3, 5. Focus, remember, it is going to have axis of symmetry horizontal. So for the focus, we are changing the x coordinate. So it's going to be -3 plus p, and y we don't, so -2, 5. Same thing for directrix, you change the x coordinate of the vertex. And it is a vertical line, so you say x equal to -3 minus the focal distance 1, so that's x equal to -4. Axis of symmetry, is the horizontal line y equal to the y coordinate of the vertex, which is 5 units. Okay, so let's try to understand that in the context of the parabola. So we're going to draw it. Let's first get the directrix at x equal to -4. So 1, 2, 3, 4, this is the directrix, x equal to negative 4. The vertex of the parabola is at the point negative 3, 5, x equal to negative 3, y equal to 1, 2, 3, 4, 5. And since the focal distance is 1, p is 1, it's positive, this is going to open towards right. So that would be the parabola. Axis of symmetry is horizontal line y equal to 5. The focus of the parabola is going to be the point negative 2, 5. Alrighty. This time x is squared, so the axis of symmetry is vertical. We're going to write it first as x minus 4 squared equal to 4 times negative 3 times y minus 1. That's our usual process. So that I know h is equal to negative 4, k is equal to 1, p is equal to negative 3, that's less than 0. Parabola opens downward. Vertex of this parabola is negative 4, 1. Focus and directrix, this time we're going to change the y coordinate. So first you will say negative 4, 1 plus negative 3 is the focal distance. So this is negative 4, 1 plus negative 3 is negative 2. Directrix, you subtract the p this time. So you're going to say y equal to, because that's going to be horizontal line, the y coordinate of the vertex minus 3, so that's 1 plus 3, so 4 means y equal to 4. Axis of symmetry, that is going to be vertical line x equal to the x coordinate of the vertex negative 4. So again, we're trying to understand the picture. I will first do the directrix at y equal to 4. So 1, 2, 3, 4. That's the directrix. The axis of symmetry is at x equal to negative 4. So 1, 2, 3, 4. X equal to negative 4. Vertex of the parabola is at negative 4, 1. So x equal to negative 4, y equal to 1, and the parabola opens downwards. Remember, p is negative. And the focus of this parabola is negative 4, negative 2. So negative 4, 0, 1, 2. So there is the focus, negative 4, negative 2. And the vertex, as usual, is negative 4, 1. So that is what we are going to understand as the context parabola from this given standard form of the parabola. All right, so that concludes this problem. The next problem is find the focus and the directrix of the parabola with given equation, then graph the parabola y squared equal to 24x. So that's simple. You will say y minus 0 whole to the power 2 is equal to 4 times x minus 0. So h is equal to 0, k is equal to 0, p is equal to 6, that's greater than 0. Now remember, y is squared, so this time the parabola will have axis of symmetry horizontal, so it's going to open right. I need to know the vertex, that's simple, 0, 0. Focus, you are supposed to change only the x coordinate, so it's 0 plus the focal distance. So this is 6, 0. Directrix, again you are supposed to change the x coordinate, and this time the directrix is going to be a vertical line, so x equal to 0 minus 6. So x equal to negative 6 is the directrix. Axis of symmetry is horizontal line, so that should be y equal to the y coordinate of the vertex equal to 0. So let's try to understand that in context of the parabola. First do the axis of symmetry or the directrix. Axis of symmetry is y equal to 0. So that is your x-axis. Directrix is at x equal to -6. 1, 2, 3, 4, 5, 6. So that is the directrix. Focus of the parabola is at 6, 0. So 1, 2, 3, 4, 5, 6. So at this point, 6, 0 is the focus. And the vertex of the parabola is 0, 0. And it is opening right. So that is the shape of the parabola. And that answers our question. And this also brings us to the conclusion of this section. So we have done only 2 different formats of parabola having axis of symmetry, vertical or horizontal, and their corresponding directrix, focus, axis of symmetry, and the vertex. So keep working on your homework problems. Let me know if you have any question. There are 2 more conic sections I need to talk about, the ellipse and hyperbola. We'll do it in our next couple of videos.